Hello students, in this video I want to explain about what do what do all acids and bases have common? What do all acids and all bases have in common? What is the common element in acids? Tell me now. What is the common element in acid? I am writing few acids like HCl, H2SO4, HNO3, weak acid CH3COOH. These are the acids. What is the common element in all these? Tell me. Okay, here we have to remember one activity. When metals react with acids, so one gas commonly liberated. Whatever the metal you taken and whatever the acid is there, so it gives that one gas. What is that gas? Hydrogen gas. When metal react with acid, it gives the salt and hydrogen. That means based on that activity we can say that so hydrogen is the common in all acids. Hydrogen is the common in all acids. Understand no? So what is the common in all acids? Hydrogen is the common in all acids. If it is acid, compulsory it should have the hydrogen. So hydrogen is the common in all acids. Now I am getting one more doubt. Do all compounds, so many compounds are there, do all compounds containing hydrogen are acids? So many compounds containing hydrogen. All are acids. Let us take some examples. I am taking C6H12O6. Here hydrogens are there or not? C12H22O11. Okay. C2H5OH. All are having here. This is the nothing but glucose. It is a glucose. It is the sucrose. It is the alcohol. It is the alcohol. Here, these are all acids we know. Here also so many hydrogens are there. Here also 22 hydrogens. Here 5 plus 1, 6 hydrogens are there. Do all of these compounds containing the hydrogens are acids? How to prove it? So to prove that, there is one experimental setup required. So for that purpose, we have to take a beaker. A beaker is there. In this beaker, we have to keep the rubber stopper, rubber cork. Rubber cork is there. To this rubber cork, just immerse. Okay. Hammer 2 nails to the rubber cork. Now we fix 2 nails to rubber cork. These are the 2 iron nails. Next, take 2 wires. 2 different colored wires, and this one end is connected here and the other end is connected to a key. Key means what? Switch. Okay, and it connected to the bulb and the bulb to battery and a cell. So here also this connected to this iron nail and it is connected to the battery directly. So the smaller one, you know that this is the negative, the larger line indicates the positive. Okay, here one switch is there, a bulb is there, a battery is there, a beaker and a cork containing 2 iron nails. Connection is there, circuit is there. When you switch on, circuit closed. Okay, like that. But here there is a gap in between these 2 iron nails. No, even if you switch on also, here circuit is not closed. If your circuit closed, then only light goes. Okay, now what I am doing to prove that all compounds containing hydrogens are not acids. To prove that, I am preparing 4 solutions. In the first beaker, I am taking the HCl solution. In the second beaker, I am taking H2SO4, sulfuric acid. In the third beaker, I am taking glucose. glucose solution. In the fourth beaker, I am taking alcohol solution. Okay, alcohol solution. So I prepared the four solutions: HCl, H2SO4, glucose, and alcohol solutions. Now, what I am doing? First, I am taking this HCl. Okay. So now I am adding this HCl to this beaker and switch on. When I switch on, this is a dilute HCl, dilute sulfuric acid, aqueous glucose, aqueous alcohol. In all beakers containing water also there. Okay, water compulsory. When I pour this HCl here, when I switch on, bulb glows brightly. Bulb glows brightly. The case 1. Case 2, after that I removed that. Okay, and now I am bringing this one. Okay, so when I add this sulfuric acid here, what happened? There also, when I switch on, bulb glows brightly. Over. Next, I remove this beaker and I am adding one more beaker, glucose beaker here. When I switch on, bulb does not glow. Case 3, bulb does not glow. Here case 1, case 2, bulb glows. Case 3, bulb not glow. And in alcohol also, when you pour the alcohol, bulb not glow. Why here bulb glows? Because when I add the HCl here, here actually open circuit is there. Something required to connect it. To pass the electron, something required. Okay, electricity, something required, ions required. So when I add the HCl, already HCl in a aqueous medium, the HCl gives generally in water, it gives that H plus and Cl minus. So in that H plus and Cl minus is there. Ions are there. That's why the ions are taking the current from one iron nail to other end. That's a circuit closed and bulb closed. Even though if you take the sulfuric acid, sulfuric acid in presence of water, okay, in presence of water, it gives H2H plus SO4 minus. SO4 minus 2. It gives two ions, hydrogen ions and the sulfate ions. So these ions are helping to pass the electricity, so that's why bulb glows. Next, if you take the glucose, C6H12O6. In presence of water, what happened? They did not ionize. Here these two are ionized, are dissociated. Ionized means, okay, ionized means what? The molecule divided to or decompose into its ions. But here glucose does not decompose into ions, and it is same way. No ions in this. It does not produce any ions. No H plus ions or any other ions. No ions at all. That's why bulb, in the third case, bulb not glow. And the alcohol, if you take the C2H5OH, alcohol in terms of water, what happened? This also just simply dissolve, but it is not giving the ions. So same C2H5OH molecules only present, but no ions. That's why in this case also bulb not glow. Based on this activity, we can say that which is acid. Okay, that acid should contain hydrogens, but okay, the substance when it dissolve in water, it should produce H plus ions. It should produce which ions? H plus ions. That substance only we can say that acid. But some other compounds containing hydrogens but not producing the H plus ions, those are not at all acids. Okay, these are the simply compounds, not the acids. Understand? So now based on this activity, we can conclude that acid, the compounds containing hydrogens, all the compounds containing hydrogens are not acid, but the compound, okay, which is producing the hydrogens in aqueous solution, that is called acid. Understand now? Okay, here I have to say another concept. Here HCl when dissolved in water, it gives the H plus. but H plus does not exist. H plus does not exist in the form of hydrogen cation. Okay, that's why immediately it reacts with the water molecule. This H plus react with the water molecule. So water molecules are there now in that solution, acid solution. It reacts with the water molecule, gives that H3O plus. H3O plus. This H3O plus is called hydronium ion. Hydronium ion. So this hydrogen ion exists always in the form of H3O plus. That means hydronium ion, but not the H plus proton. It should not exist in the form of H plus. It's very unstable. That's why this H plus reacts with the water molecule gives that H3O plus. That is the hydronium ion. Okay. Likewise, if you take the bases also. Okay. What is the common in all bases? What is the common in all bases? What is the common in all acids? Hydrogens. In the same manner, what is the common in all bases? Let us see. I am taking few bases. You know the best example for bases: sodium hydroxide, calcium hydroxide, sodium hydroxide, calcium hydroxide, magnesium hydroxide, KOH. So like this, so many and so on. In all these bases, which is the common? What is the common in all bases? You may observe that here OH. OH, OH, OH. So you can say that OH hydroxide, OH minus hydroxide ion is the common in all bases. In acid, H plus is the common in all acids. Likewise, in bases, OH minus is common in all bases. Got it now? So next. After this, I want to say, okay, when NaOH is dissolved in water, what happens in terms of water? It gives that Na plus and OH minus. And CaOH taken plus dissolved in water gives that Ca plus 2 plus OH minus. 2OH minus. MgOH taken twice also, here Mg plus 2 plus 2OH minus. So like that. KOH also gives in terms of water. So here all water required here. In terms of aqueous medium, it gives that K plus OH minus. So one cation and anion is released here. Anion is the hydroxide ion. Cation is the ametallic. Cation is there. And the base which is soluble in water. The base which is soluble in water is called special name alkali. What is that? Alkali. All alkalis are bases, but all bases are not alkalis. But the base which dissolve in water, okay, that base is called alkali. For example, potassium hydroxide easily dissolve in water. Sodium hydroxide easily dissolve in water. Alkali. Okay. Understand now? But some bases are there. Those who does not dissolve in water. Those are called simply bases but not alkalis. Okay. And here I am going to explain about one more concept. What is the concept? Do acids produce H plus ions only in aqueous solution? I told you previously now, HCl and H2SO4 produced H plus ions in aqueous solution. So, do acids produce H plus ions in aqueous solution only? Let us find it. In non-aqueous solution, maybe they may show that they may show acidic property or not show acidic property. Let us find out. For this purpose, here my concept is, do acids produce H plus ions or hydrogen ions in aqueous solution? Let us see. Take a boiling test tube. Boiling test tube is somewhat bigger than the normal test tube. Take certain amount of NaCl, sodium chloride. Okay, 2 grams of sodium chloride. Then next, here add concentrated sulfuric acid. Concentrated sulfuric acid. And the test tube also should be dry. Take a dry test tube only, not the wet test tube. Take a dry test tube and add that. Take 2 grams of sodium chloride and add some amount of 2 ml of sulfuric acid. Then what happened? Let us see. Now we have to fix a cork, 1 hole rubber stopper, and through this just you have to fix a delivery tube. When we add the sulfuric acid to the sodium chloride, it produces a gas. This gas is passing through this delivery tube and here it is coming. So at that place, keep the dry blue litmus paper. This is the dry blue litmus. Paper. When you keep the dry blue litmus paper, is there any change? Observe, no change. Okay. Now remove this dry blue litmus paper and now bring the wet blue litmus paper. When you bring the wet blue litmus paper, it turns into red color. Generally, in which medium? Blue litmus paper turns into red color, acidic medium. Okay. That means here which gas is evolving? Maybe some acidic gas. Let us see the chemical equation here. NaCl, sodium chloride, reacted with H2SO4, sulfuric acid. It gives sodium sulfate, Na2SO4. Remember that when sodium combined with sulfate valency 2 you have to write here. Sodium valency 1 you have to write here, but 1 no need to write. So Na2SO4 plus it gives that H and Cl combined gives that HCl. If you balance it, just you have to keep the 2. Now it's balanced. Okay, 2 NaCl plus H2SO4 that gives Na2SO4 plus HCl. Got it now? Now here a gas liberated. What is this? Hydrogen chloride gas. HCl is the acid actually. But when you keep the dry litmus paper, it does not show any acidic property even though it is having hydrogen. But when you bring the wet litmus paper only, it turns into red color. It shows the acidic properties. Why? Because in dry litmus paper, the HCl is in the form of HCl only. But in a wet litmus paper, wet means H water now. In presence of water, this HCl dissolve and produce that H plus and Cl minus. In presence of H plus ions only, the blue litmus paper turns into red color. Previously, dry blue litmus paper, HCl is in the form of HCl only, gaseous form. But in the wet blue litmus paper, what happened? Certain amount of gas dissolved in water and gives the H plus ions. So, based on this activity, we can conclude that acids produce H plus ions only in aqueous solution. Acid shows acidic behavior only in aqueous solution. Next, one more. Another one you have to discuss here. Okay, while you are doing this activity, sometimes even the dry blue litmus paper also turns into red color. If the atmosphere is humid, at that time that dry blue litmus also turns into red color. That's why if your atmosphere is humid, at that time what you have to do? So we have to fix a guard tube. You have to fix a guard tube. So this guard tube we have to fix here to this test tube. What is this guard tube containing? Containing CaCl2, calcium chloride. Generally, calcium chloride absorb all the moisture. If you buy any new items like electronic goods or leather shoes, you may see that a small packet is there inside. A small silica packet is there. What is the use of that small packet? It absorbs the moisture from that box, container box. Okay, like that. If you use the guard tube, then what will happen? So it will take all the moisture, then only dry HCl will come out. When the dry HCl come out, when you give the dry blue litmus paper, no change. When you give the wet litmus paper, it turns into red color. Okay, so in this video, I explained number one, do all. So what is common in all acids and all bases? I explained. What is common in all acids and all bases? All acid H plus ion is common. All bases OH minus ion is common. And I explained one more activity. Do all compounds containing hydrogens are acids? No. How I proved that? I have taken that hydrochloric acid solution, sulfuric acid solution, glucose solution, alcohol solution by using a circuit. So when I applied that, when I switch on, what happened? In HCl, in sulfuric acid, bulb glows. In glucose and alcohol, bulb does not glow. So based on this, we can say that okay, in aqueous medium, which is giving the ions H plus ions, that is act as the acid. In aqueous medium which is not produce the H plus ions, it is not act as the acid. Okay, like that we concluded. Next, third one is, do acids produce H plus ions only in aqueous medium? For that purpose, I have taken sodium chloride and sulfuric acid. Okay, a gas liberated. When you bring the dry litmus paper, no change. Wet blue litmus paper, it changes into red color. Based on this, we can understand acids produce H plus ions only in aqueous solution. And H plus ion is generally not exist independently. So that's why H plus ion immediately react with water molecule, form the hydronium ion. What is the formula of hydronium ion? Hydronium ion formula is H3O plus. Thank you.